Hello class. Today we're going to talk about proportionality and non-proportionality. Our standard that we're going to be looking at today is 8.5F. It says that we're going to distinguish between proportional and non-proportional situations using three different things. Using tables or T-charts, using graphs, and using equations in the form of y equals kx or y equals mx plus b, where b is not equal to 0. So we're going to start off looking at graphs. Okay, so here is some examples of graphs that are proportional and graphs that are not proportional. So take a moment to look at the left-hand side, the proportional side. Do you notice anything in common between all of those graphs? Take a moment to jot that down. Okay, now I'm hoping that you notice two things about the proportional graphs. One, they're all lines. Okay, they all make a line. Two, they all go through the origin. Now, look at the right-hand side. Look at the non-proportional ones. Do they have those same characteristics? And no, they don't. Okay, one, they're not all lines. Some of them are curves, like this one down here is a curve, and some of them are zigzaggy. And two of them go through the origin, but they don't make lines. So, for proportional relationships, if it's a graph, to determine if a graph is proportional or not, it must meet two conditions. Condition number one is it must have a constant rate of change. In other words, it must be a line. It must be a line. It's not going to have a curve like this, or it's not going to have a zigzag. Right? It's got to be a line. The other thing is it must go through the origin. Must go through that center point right there. Must. Okay, so those are the two conditions for a graph to be proportional. Now what about an equation? Well, we know if it goes through the origin that an equation is going to have a slope of, not a slope, but a y-intercept of 0. So if you look at all of these equations right here, you'll notice we have a slope, but we have plus 0. We have a y-intercept of 0. We have a y-intercept of 0. Plus 0, a y-intercept of 0, plus 0, a y-intercept of 0. Because our y-intercept, when we're looking at this, isn't the y equals mx plus b is always that b number. Okay, so all of those proportional, they have a y-intercept of 0. If you look at the non-proportional, this one has a y-intercept of 2. This one's got a y-intercept of -4. This one's got an exponent. That means it's not a line, it's going to have a curve. And this one's got a y-intercept of 1. So all of these, none of them will go through, well, this one will go through the origin, but the others, they won't go through the origin. And this one goes to the origin, but it's not a line. Okay, so it doesn't fit the description, doesn't fit the definition. So what makes an equation proportional? These things right here. One, it must be a linear equation. Okay, it must make a line. In other words, it can't have any exponents. And only a number times x. The y-intercept must be 0. So when we look at this y equals blank x, this m is going to have a number, but my b is just going to be plus 0. Okay, so you will have a y-intercept of 0. Now, a lot of times whenever we have just blank x, this m that we have, it changes to a k, referring to constant of proportionality. Our next lesson will talk more about that. Okay, now let's look at this in terms of a T-chart. Now the T-chart is the toughest one to determine because again, it's got to meet some conditions. But we know if it's if a line, it has to be in the form of a line, then that means that I must have a constant rate on both sides of my T-chart. Okay, so number 2 here says it must be the same ratio throughout the whole table. In other words, as I'm counting down the y, it must be the same as counting down the x. Okay, and it must go through the origin. Okay, so in order to determine that, let's say this T-chart right here doesn't have the origin. Okay, we don't have it, so let's find out if it could have it. So the first thing I do is I find my pattern. Okay, my pattern on the right-hand side is 4. Is it the same all the way? Yes, it is. My pattern on the right is 1. Is it the same all the way down? Yes, it is. So we know that if I take my delta y and divide it by my delta x, I end up with slope. So 4 divided by 1 is 4. So in order to determine if 0, 0 is part of my T-chart, I take my slope and I multiply my x value by it. 3 times 4, that gives me 12. Is that what's in the y spot? Yes. 4 times 4, 16. 5 times 4, 20. So that would mean that if I had a 0 there, 4 times 0 is 0. So 0 would be part of this T-chart. So is this proportional? Yes. Okay, now in this one, I have a 0, 0. Okay, so I automatically know it meets one condition. The other condition it must meet is it must maintain a consistent pattern all the way down. So this one has a pattern of 9. This one has a pattern of 1. Is it 9 all the way? Yes. Is it 1 all the way? So yes, this is proportional. Let's look at some non-proportional. Let's see if we can meet those same conditions. Well, this one doesn't have my 0, 0, so I check it. I look for my pattern. 10 to 4 is 4. Is it all the way down? Yes. 6 to 8 is 2. Is it all the way down? Yes. 4 divided by 2 is 2. So when I take this x value, multiply it by 2, 6 times 2 should be 12. What do I get? I got 10. Uh-oh. So that means 0, 0 is not part of this T-chart. So this is not proportional. Same thing for this one. My pattern here is 2. My pattern here is 1. So when I back up 1 to 0 and I back up 2 here, I end up with a 2 and not 0, 0. So that's the sign of being proportional or not proportional. So we've looked at three things. We've looked at a graph. A graph must be a line and must go through the origin. Okay, an equation must have just a slope. The y-intercept is going to be 0, and it can't have any exponents. And with the T-chart, it must contain the origin. It must have the same ratio throughout the T-chart. So let's put you to the test. Let's see if you can actually identify some as being proportional or non-proportional. Here's the first one. Is this table proportional? Pause the video and say yes or no. Okay, so let's find out. In a T-chart, it must meet two conditions. It must contain 0, 0, the origin, and it must maintain a pattern throughout. So 8, is it all the way 8 all the way down? Yes. 1, is it 1 all the way down? Yes. Okay, so this one is proportional. Okay, so yes. Now the next question is, what is the rate of proportionality then? Well, rate of proportionality or constant of variation or constant proportionality, okay, all of those are just fancy ways of saying if this T-chart is proportional, what's the slope? And in this particular one, the slope is 8 or 8 over 1. Okay, next one. What about this one? Okay, again, we don't see the origin, so we got to find it. Okay, let's find our pattern first. Pattern here is 8. Our pattern here is 2. 8 divided by 2 is 4. Okay, so to test it, we take this number right here, we multiply it by 4. Do I get the y? 2 times 4 is 8. 4 times 4 is 16. 6 times 4 is 24. So is this one proportional? Yes. Okay, and then again, if it is proportional, what is our rate of proportionality or the slope? And in this particular one, our slope is 4. Okay, what about this one? Okay, so again, I don't have the origin, so I look at my pattern. My pattern here is 6. My pattern here is 2. Is it 6 all the way down? Yes. Is it 2 all the way down? Yes. 6 divided by 2 is 3. So then I take that 3, I take my slope, I take my x value, I multiply it by 3. 3 times 3 is 9. Uh-oh, and I got 12. So is this one proportional? No. Okay, so what is the rate of proportionality? Well, in this one, there isn't a rate of proportionality, so we would say none. Now, it still has a slope. The slope is still 3, or 3 over 1, but it's not proportional because it doesn't go through the origin. Okay. Now, what about a graph? Which one of these graphs is not proportional? Good, D, okay? Because A is a line, B is a line, C is a line, and they all go through the origin. D goes through the origin, but it's not a line. So this one is not proportional. What about number 2 here? Okay, well, which one is not proportional? Well, A, it is a line, goes through the origin. C is a line, goes through the origin. D is a line, goes through the origin. B is a line, but doesn't go through the origin. So it is not proportional. Okay. What about an equation? Good. A is not proportional. A has a y-intercept of 3. C has a y-intercept of 0. B has a y-intercept of 0. And D has a y-intercept of 0. So A is the one that is not proportional. Okay. What about a couple T-charts? Okay. Well, again, it doesn't have 0, 0, so I look for my pattern. My pattern here is add 2.5. My pattern here is add 1. Is it consistent on both sides? Yes. So I just work it back 1 to get my 0, and find my 0. So yes, this is proportional. Okay. What about this one? Well, again, it doesn't contain my 0, so I find my pattern. This is 10. Is it the same all the way? Yes. This is 2. Is it the same all the way? Yes. 10 divided by 2 is 5. 3 times 5 is 15. 5 times 5 is 25. 7 times 5 is 35. Is this proportional? Yes. Last one. Is this one proportional? Well, again, it doesn't have my 0, so I got to check it. My pattern here is plus 0.6. Okay. Is it the same all the way throughout? Well, if you look at this one, my pattern is, my difference is 0.4. And then back to, and then 0.8. So my pattern's not consistent here. Even though my pattern's consistent here, my pattern's not consistent here. So this one is not proportional. So what you've learned today is how to determine whether or not a graph, a T-chart or table, or equation is proportional or not. So until next time.